Okay, let's have a look at class example number 5. We're going to determine trig ratios from a point that we know on the terminal arm. The point -15.8 lies on the terminal arm of a rotation angle in standard position. So what that means is, this is at the actual angle, and this is the terminal arm, the ending arm of that angle, okay, where it ends up. So it asks us to mark where angle theta would be. Angle theta would be this angle, okay? Now, it also has asked us to calculate the exact length of OP. So in other words, what is marked on this line as R, our hypotenuse. This actually makes a right degree triangle if we take this line down to the x-axis, okay? And in that case, then we know that if this distance is directly below -15 as our x, then this x is -15, and this y value, the vertical value, would be y is 8, right? Okay, so when we know we have a right angle triangle and we know a side length, two side lengths, and we're trying to find r, our hypotenuse, we can always use the Pythagorean theorem to calculate the hypotenuse. Now, no matter what level math course you take, right up to the very complicated and tricky math courses that you may take in university, you will always come back to the Pythagorean theorem. It's just kind of one of those core values. Okay, so the Pythagorean theorem says that our hypotenuse, like c squared normally on a regular triangle, but because this is in terms of trig ratios, we're using r as our hypotenuse. So r squared is going to be -15 squared plus 8 squared. And when you plug this into your calculator, just make sure you keep that -15 in brackets so that it's seeing that as a one whole quantity that it is squaring. And when you do -15 squared plus 8 squared, it'll give you that r squared is 289. And then to solve for r, you would just take the square root of that, which is 17. So what that's telling us then is that OP, or in other words our r, is 17. Okay, now it asks us to use our x value of -15, our y value of 8, and the r that we calculated in the B above to determine the exact values of the primary and reciprocal trig ratios for angle theta. Okay, now when it wants exact values, what that means is you're going to leave it as a fraction. You're not going to actually take it to a decimal point because the decimal could keep on repeating and you would have to round it, and that wouldn't give you an exact value. Okay, so when it says exact value, you leave it as a fraction. Also, if we need to find the trig values for angle theta, that's this angle here. But we learned just a minute ago that they are the same as the trig values of the reference angle, which is this angle right here. Okay, so that's why we can use the triangle we have to find the primary and reciprocal trig ratios. It's going to be the same as the primary and trig ratios would be for theta. Okay, so we're just going to write sine of theta would be, cosine of theta would be, and tangent of theta would be. And then we're going to put what the reciprocal would be. Well, the reciprocal of sine, well, there's no co in that, so there must be a co in it. Cosecant, because remember every pair has one co. Okay, cosine, well, it's not going to have a co in it then. The reciprocal of it is secant. And then tangent, the easy one, the reciprocal of tangent is cotangent. Right, okay. Now let's put in terms of x, y, and r, the sine ratio is y over r. So in that case, its reciprocal would be r over y. The trig ratio for cosine is x over r, so its reciprocal would be r over x. The trig ratio for tangent is y over x, so its reciprocal would be x over y. Okay, now we can fill in those values. Okay, our y is 8, our r is 17, so the sine of theta is the same as the sine of its reference angle, so the sine of theta is 8 over 17. And then its reciprocal would be 17 over 8. Cosine is x over r. Well, our x is negative 15 over our r, which was 17. So the cosine of the reference angle is the same as the cosine of theta. And then the reciprocal would be negative 17 over 15. You just flip the numbers. The negative sign really is out front. It doesn't matter whether it's in the numerator or the denominator, or whether it's out front. If there's one negative sign, that makes no difference. Okay, tangent y over x, that's negative 8 over 15. So if you take the reciprocal of that, then that's 15 over 8, and the negative is still there. All right, the very last question, last example we're going to do, using one trig ratio to determine other trig ratios. Okay, so what this tells us is that cotan of A is the square root of 5 over 2, and that sine is negative. Complete the following procedure to determine the exact values with rational denominators for cosecant A and secant A. Okay, so first of all, as Mrs. Baker always says, we're going to draw this. Okay, so first of all, if we know that all suckers take chemistry, okay, now let's look at what we do know. We know that cotan is square root of 5 over 2. Cotan is positive, in other words. Okay, now what is its reciprocal? Tangent. Okay, so since the cotangent is positive and its reciprocal is tangent, that means if tangent is positive here, then cotangent would be positive there too, right? Okay, where else is tan positive? It could be quadrant 4, but it's also positive in quadrant 1, okay? So we know we're talking about either quadrant 1 or quadrant 4. It's this second bit of information, the fact that sine is negative, that's going to help us figure out whether we're talking about quadrant 1 or quadrant 4. Where is sine negative? Well, sine is not negative here. It's positive there. Sine is negative here. Okay, so we know that this quadrant must be in this, or this angle must be in this quadrant. Okay, okay, so we're talking about this angle that must terminate in quadrant 3. Okay, what other pieces of information do we know? Okay, well, if we know that cotan is the square root of 5 over 2, this actually gives us our x, and it gives us our y value, doesn't it? Okay, so let's actually, I'm going to just make this line a little longer and put back t in this quadrant. So if I know that this is a point here, and I know that my x value is the square root of 5, let's see, I could make my triangle here. Okay, and that means that this x value here is root 5. But when I look at this diagram, does that make sense? That my value on this x-axis on this side of y would be positive root 5? No, it must be a negative root 5. Okay, I also know that my y is 2. And again, does that make sense looking at this diagram? No, that must be a negative 2. However, when I put that in a ratio like this, negative root 5 over negative 2, it's going to give me just root 5 over root 2, because those negative signs will cancel each other out. Okay, right? So that's why the cotan of A is root 5 over 2. Okay? Okay, and then we also know then that this hypotenuse would be R. Okay? Now it says to us, sketch the diagram and draw the reference triangle illustrating the above information. So this is the reference triangle that we drew, the 90-degree triangle. Then it wants us, to label that point then. We know that this point is on there, so that would be the coordinates of this point then. It's negative root 5 for our x value, and it's negative 2 for our y value. Okay, C asks us now to use the Pythagorean's theorem to determine the value of R, and then to determine the exact values again of cosecant A and secant A. Okay, so Pythagorean theorem, x squared plus y squared equals r squared. So my x squared would be negative root 5, and I need to make sure I bracket that so that that whole value is being squared, plus negative 2 squared is going to equal r squared. Okay, well, negative root 5 squared is just 5 if you plug that into your calculator, and negative 2 squared is 4. Oops. So 9 equals r squared, so r equals 3. Take the square root of both sides. R is 3. Once we know that, then we can figure out cosecant. Which is a cosecant of A. They're calling this angle in here A. Okay, so cosecant A is R over Y, and secant A, well, secant would be R over X. Okay, so R over Y, our R value is 3, our Y value is negative 2, so negative 3/2 is cosecant A, and secant A, R over X, well, our R is 3, our X is negative root 5, and of course we would not normally leave it with a square root sign in the denominator. We learned last year in our radical unit that that's not in simplified form. So to simplify that, we multiply by root 5 over root 5, which is really just 1. So we're not changing the value at all, but it will get rid of our root sign in the our square root sign in the denominator. So we've got 3 root 5 on the top, and on the bottom we've got root 5 times root 5 is just 5, but we still have our negative sign. Okay, so negative 3 root 5 over 5 is secant of A. Okay, and we are going to leave this assignment as is. We're going to do questions 5 to 15 to get some practice with this. So hopefully between the lesson that was split into 2 halves today, it's been a good review for you about some of the trig ratios that we learned last year, and also a little bit new with the reciprocal functions, or the reciprocal ratios. And I hope that you can finish those questions all before class on Monday, so that you'll be ready for the next topic that we're going to cover on Monday.